So we're trying to find the inverse derivative here. Here's what I'd like you to do, okay? I always am going to write two different ordered pairs. I'm going to write the original ordered pair, and I'm going to write what the inverse ordered pair is. Okay, the original ordered pair and the inverse ordered pair. What's our ultimate goal here? Our ultimate goal is to find the derivative at what? 7. Our goal is to find what is the derivative at 7. So that 7 is with my inverse, okay? That's what the -1 means. That's my inverse point. So that 7 is going to be part of my inverse. If I'm finding the inverse at 7, do you think that's my x value or my y value? That's my x. So that 7 right there is what I'm trying to find the inverse at 7. Okay? So if I'm finding the inverse at 7, where does this 7 go in terms of the original ordered pair? The y. If it goes here, it's really the y value of the original. So if my original order, I want to know what my original ordered pair is. I want to fill in the rest of this. If this is 7 and this is 7, the y value of the original is 7. What's the x value or the other number that I'm missing here? 3. Why 3, DeMarcus? This right here, this 7, f is 7. That's his y value. Oh, his y value is 7? Oh, that means his x value must be 3. This number is 3. If that number is 3, what does that mean about my inverse? It's 3. All right? So I'm going to write this out in words. So that way we can see it. If you want to know what f prime is at 7, I really want to know inverse f prime. It's the derivative of f prime. I just don't like writing it the way they write it. It gets weird. What the derivative of the inverse is at 7, if I want to know that, I really need to know, if you want this, you need f prime at 3. You need to know what the derivative is of the other value. If I want this, I really need that one. Okay, I want to know what the original is at 3. So what is f prime at 3? We do know. F prime at 3 is 4. So if f prime at 3 is 4, this is I hate that they write it like this. Sorry. d over dx of the inverse at 7. If that one is 4, what is the inverse derivative going to be? 1/4. We take the reciprocal. It's weird, but look at it again. Let me explain it again. Okay? You've got your ordered pairs. Make sense on the ordered pairs? Okay? I want to know 7. That means I really want to know what the original is at 3. If you know what the derivative is at 3, hey, it's 4. Then I did the reciprocal of that. It's 1/4. It's weird. That's what we just explained on the front side. It's way easier with a picture. We don't have a picture here. We have an equation. You just got to figure it out. Okay? The first one's weird. After the third or fourth one, it'll make more sense. All right? Let's go to the next one. And part of it's weird because I can't write h prime because it looks weird. All right, here we go. So I look at this and I'm seeing inverses. I know I need two things. I need to know what the original point is, and I need to know what the inverse point is. In the end, what do I want to find the derivative of? I want to know what h of 9 is. Okay, I want h at 9. So that's the inverse. That h right there is my inverse equation. Since that's what I'm finding, that's going to be my 8. That's going to be my inverse. So which equation is my original equation up here? Or which letter is my original? F. H is my inverse. And it doesn't matter which one you call which. It's not going to, don't let that bother you. H and F are inverses of each other. So one of them is the original, one of them is the inverse. I'm trying to find the inverse. It's not going to matter because it's really just flipped. It doesn't really matter. All right? I'm going to always say whatever one I'm trying to find is my inverse one. That's always how I'm going to do it. All right? So I want h at 9. So that 9 here, is that my x value or my y value of the inverse? That's my x. So what is that going to be of my original? It's going to be my y. Okay? There's that. It's 9 and 9. Okay? So I'm saying right now that I want to really know, I really want this part. That's the number that I really care about. All right? If I want to find h at 9, I need to know what f is at the other number, at the x value. Okay? Or at this value. So if my f value, I want a y value of 9, what's the x value going to be? 2, right here. F is 9. Oh, then my x value is 2. This is 2. This is 2. So if I want to know what h is at 9, I really need to know what f prime is at 2. And this should be h prime at 9 and f prime at 2. Okay? So my job here is to find h prime at 9. So it's really going to be 1 over the reciprocal of whatever f prime is at 2. What is f prime at 2? 1/2. So it's 1 over 1/2. Because of this right here, it's the reciprocal of f prime at 2. So what's my answer really going to be? 2. Because it's 1 over 1/2. It's the reciprocal of the reciprocal. It's 2. Little better. I know it's not perfect yet. Maybe it's a little better. Okay, let's go to the next one. I'm going to set it up and see if you can do the rest of it. I see f, I see g, I see inverse. As I read this problem, I know that I need to set up two things. I need to know what's my original point. I need to know what's my inverse point. In the end, my job is to find, I want to know what g prime is at 8. So if I want g prime, that means g is going to be my inverse equation. What's my original equation going to be? My original is going to be f. F and g are inverses. So that means I need to know what f prime is at the other number. I want to know g prime at 8. Oh, cool. Then my x value is 8. Then I need to know what f prime is at whatever that is, because I'm going to have to take the reciprocal of it. Go ahead and try to finish that. Shouldn't take super long, but see if you can finish it. So if I'm trying to find g prime at 8, what's the missing number? 3, because f at the y value is 8. Oh, I want the y value is 8. That means the x value is 3. I need to know what f prime is at 3. So for me to find g prime at 8, I really want to know what 1 is over f prime at 3. I want to know the reciprocal of f prime at 3. So f prime at 3 is 5. So my g prime at 8 is going to be 1/5. Again, the math, not hard. The math isn't hard. It's the concepts and the connections that are making this difficult. All we have to do is take a number and flip it. But it's just the way to get there is a little bit tough. All right, let's try another one. You good, Grace? Okay. All right. Finding g prime at 3. I see inverses. All right. So I want to know original point. I want to know what the inverse point is. I want g prime at 3, so I'm going to call my inverse g. So what's my original going to be then? F. I want g prime at 3. So that means I need f prime at not the same number. I want g prime at 3. So then I need f prime at a different value. They didn't give me numbers here. It's not as easy as looking up at the top and making that decision. What can I do here? Good. Yeah, we want to know when the f equation is equal to 3. So Joel and DeMarcus said here that we want to set this thing equal to 3. So I'm going to say 3 equals x cubed minus 5. Add 5. Cube root it. What number multiplied together 3 times is going to give me 8? X is 2. X is 2. X is 2. That means I want to know what f prime is at 2. Go ahead and try to finish that problem. How am I going to find f prime at 2? Take the derivative of this thing. So I'm going to find f prime at 2. So it's going to be 3x squared. That's what the derivative is of that. I'm going to plug in 2, so it's 3 times 2 squared. So 2 squared is 4 times 3 is 12. F prime of 2 is 12. That's great, but that still doesn't give me my answer. I want to know what g prime is at 3. If f prime at 2 is 12, what is g prime at 3 going to be? The reciprocal of it, it's 1/12. Questions? Again, the math isn't hard. The concept, the connection is the place we're struggling. I feel like if you write it out that way, you're going to be a lot better off than trying to just do it memorization. Writing out the original, the inverse with the letters, saying what you want and what you need, it'll help you to get things on a better path. Questions?